Hello everyone, welcome back. So today we would be discussing the recent Codeforces contest with the educational round, and I was able to solve ABC till now, so I was making the video right now. Struggling with D's, I'm trying to solve the D. If I would be able to, I would add in the solutions part as well. So let's start with the A problem. So A problem was very easy. So it was given that you are given some individual key and a group key, and your cost is $B. Okay, and you need to access the three. Okay. So if I explain you the problem statement, so the problem statement is saying that you are given with a key, and keys are A and B. For A, it would be like working as a single unit. It would be working as a single unit, and it would be serving as three, like at most three number of students. Okay. So what you have to find is, here I have to find the minimum cost to actually tell that what would be the minimum cost. Okay. So minimum amount you need to provide the online courses for all the N students. Okay, so it would be quite easy. So what if I say, you might be thinking that if it's serving three particular students, then obviously then I should go for B, but that's not the case. So you have to take care of a case that if 3 times of A is less than B. Okay, if we talk about the 3 students, okay, A, B, and like these are the 3 students we talk about. So if we take the keys for them individually, so it would be A plus A plus A, that would have been 3A, or there could be a possibility that it could all be combinedly served by B, right? So if your 3A is already less than B, then can you say that it would be better to choose that A key for each of the students? So it would simply be NA, right? Else it would be less than equal to condition. Else if your B is greater than 3A, then there would be a possibility. Then what you would be doing is, you would be doing B by 3 into not B by 3, it would be N by 3. Like you would be taking all the possible groups of triplets, right? N plus, which would have been minimum of either A into N modulo 3. Like let's suppose you are left with 2 children or 1 children, and then you have to check whether I need to give A keys to that particular student or a single B key to that particular student. So this would simply be our answer. If I show you the code as well, let me load the code. In the meanwhile the code is loading, let's discuss the next problems as well. Yeah, so if we see the code, it's been simply written in the similar fashion. If N modulo 3 is, then it would simply be B, and like there I've made up a simple check over it. If it's divisible, then it would simply be here, else it would have been this, and this could be easily omitted because here it would simply be 0, so it would simply be B only. So like this is how we actually write this code of this problem. Now let's jump to the B problem. Okay, so the B problem was quite tricky in terms of understanding the problem statement. So let me first give you the idea of what the problem statement was saying, then we'll discuss. Okay, so if we talk about B, so what B was telling is that you are given with this particular string, right? So you are given with a string, and what you have to do is that you need to remove some characters. You need to remove some characters such that remaining string is not divisible by 4, right? It's not divisible by 4, and that particular string is known as a beautiful string, right? If a string, it's already written in the question also, the string is beautiful if it's impossible to select some of the elements and write them out to form a number that is a multiple of 4. For example, this is a beautiful because these all are not multiple, like not divisible by 4, and these are not beautiful because if I remove 1 and 3, then 4, this would easily be divisible by 4. For 3, 1, 2, 3, I would have taken 12 and it would have been divisible by 4. So you need to tell minimum number of elements you need to remove, right? Okay, so this was actually also an easy problem, just you need to make cases and you need to take care of few and here and there steps. So if I tell you, here in the string you are given with only 4 type of characters, either 1, 2, 3 and 4. Now remember the divisibility test of 4, right? If I tell you the divisibility test of 4, what it says is last 2 characters should be divisible by 4. It should simply be 0, 0, or last should be divisible by 4, right? So 0 0 cannot be possible because our characters are only 1 2 3 4. So and what case can I say my last characters would be divisible by 4? If it's a 12, or if it's a 32, or if it's something like 24, right? So this would all be the possible cases, or it could simply be the 4 as well. Like if at any moment my string could land up to 4, then also my string would be divisible by 4. So first thing and foremost, you would be able to think that let's remove all of the 4s, right? This is the bare minimum we have to reduce, right? Because if any 4 is left in the string, I could delete all of the characters, and this particular string would only be divisible by 4, right? So first we'll remove all 4s, right? Now what we have to deal is 1 3 and 3 2. So from this we actually came to know that if we talk about some ith index, and which a of I is equals to 2, where a of I equal to 2, then if there is any 1 or 3 before this 2, I have to remove that, right? I don't care about this 1 and 3 before after 2, but if there is before 2, then I have to actually delete them, right? So if we talk about at some ith index, if I talk about some ith index of an array, where a of I equal to 2, then can I say after removing all of the 4s, can I say before this would all be 2s only, right? And after this there could be 1 3s or 3 1s, right? It was something like this, and before this it would be something like this. So this is what you have to actually compute for each ith point. You just need to check for the count of what is the count of 1 or 3, and what is the count of 2. Whichever is your minimum, you will take that as an answer. So let me show you the code as well. What I'm trying to say is, so this is simply, let's count what I've done is I've simply counted how many number of 4s are there and how many number of 2s are there, and my answer would be either, what I've done is the answer simply would be either I remove all of the 1 3s before 2 or remove all of the 2s, whichever would be the minimum, I would do that. But there would be some cases where this would fail, is where you have only 1 2 2 1, like it's something like this, there are no 3s. So in that case you have to like this would be some kind of an HK. So that's why I've come up with this particular logic, where for every ith index you need to check that before that there should be no 1 or 3, and after that there could be 1 or 3 possible, right? So this is what we have done. For each I, what we are checking is what is the count of 1 3s and what is the count of 2, right? If your count of 1 3 plus your count after that, like the count of 1 3 over here, and the count of remaining 2s, that the remaining 2s you have is less than your current answer could be remove all of the 2s. If it is less than that, then just simply update your answer, and at the final what you have done is answer plus count of 4s. So this is how you would be solving the problem B. This was actually an easy problem, just you need to take care of this particular intuition that this could fail at something at this point as well, so, or some of the edge cases here, so you just need to deal with that. So okay, so let's discuss the C problem as well. So C problem was actually also a good problem. Let's discuss this part. So what the C problem is saying is, so C problem was saying that for some C of I, okay, that C of I is the Ci is the number of cards of type 1, C2 of type 2, and till Cn of type n. What you have to do is you have to arrange them in a circular order, like in a circular fashion, such that 3 consecutive cards, if I take about this particular 3 consecutive cards, 2 of them should be same. Any 2 of them should have been the same value, right? Let's discuss with the test case as well. So if we talk about this particular test case 1 1 1 3, so if I talk about 1 1 1 and 3, so this is 1, this is the value 2, this is 3, and there is 4 4 and 4. So what it actually means is, what they want to say is, so if you arrange, so what they are saying is, if you arrange this particular into some circular permutation, let's suppose we have made this particular permutation. So if we talk about any set of three values, right, this this or the circular one, all have at least two values are same. So this could be the possible length of the, like this could be a one possible pair, right? So you need to find the maximum number of cards that you can arrange, right? You need to find the count. Okay, so now let's discuss how do we actually solve this problem. Okay, now if you would have solved this, like, or give some time on this problem, you would have come up with a simple idea of that if your count of distinct values, like whose it's not 1, is 0, then means all are ones, kind of, I would say. So in this particular case your answer would simply be 0, because you cannot arrange them in such a fashion that it would become a, like it would satisfy this particular scenario, right? This particular condition would be failing, right? Now let's see how do we actually like, let's now delve deeper into this intuition part of this. Okay, let me give you a name. Let me define a weak card and a strong card. Okay, the weak card is the count whose frequency or count is 1, like whose count is 1, and here the strong card is whose count is greater than 2, like greater than or equal to 2. So like it's greater than equal to 2. Okay, so now what we'll be doing is, if I want to place a weak card, then I would be at least have been placing a strong card here and a strong card here to make this particular pair as a safe pair, like this particular triplet as safe. Then only I would be able to say that this particular triplet is safe. But if you zoom it a bit, like if you say this is a weak card and here is a strong card, if I talk about this particular triplet, here is a question mark, and or this particular triplet, here is a question mark. So here also, to make this triplets also safe, do I need a strong card here as well? Yes or no? Like I would be needing a strong card here as well, right? So and this strong card should all be of same type, right? Should all be of same type. Then only I would be able to make it a pair, right? So this is what the logic we would be using. So if this particular count, like if the count of strong is equals to 0, then your answer would simply be 0. If your count of strong is equals to 1, that there is only one type of strong cards exist, then your answer would have been simply be, like what you would have done is like it would simply be the count by 2, because it would simply be the total number of possible pairs that you would have been taken, right, plus the minimum number of and let's assume that this particular count, there is a count of weak as well. Let me denote it by W. So here would have been CW, which would denote the count of weak, right, and C by 2, right? So this is only we can say, right? So this was the how many cards that you would be able to arrange. Okay, let's take an example as well. So let's suppose let's take this particular example only. Here your CW is 1 and your CS is actually 3, right? So if we talk about how many cards that you can arrange is, it would have simply be it would not be C only, it would be C, right? So here how many cards you would have arranged is C plus the minimum of this particular thing, right? So here C is 3 plus the minimum of CW and C by 2. C by 2 is actually 1, and here also CW is also 1, so minimum is 1, and here 4. So this is the four cards that you can easily arrange. I hope you would be able to think what I'm trying to say over here. So like if you think it a bit, like if you have a strong card and a weak card over here, then you have a strong. So this is a particular, I would say, a pair or a what we call it as a bracket or something that would exist. Okay, now let's delve the case when you have multiple strong cards, right? example, let's suppose you have some 5s and some 8s. Example, let's take this particular case. So what I'm trying to say is, so let's consider this particular case where you have 6 8s, right? 6 8s. So if you would have placed something like this: W1 8 8 W2, then 8 and 8, right? And here you would have thought of placing some weak elements W3 and W4, but you cannot place this W3 and W4 over here, because before W4 and after W3 there would be some another pairs, let's suppose 5s 5s and 5s 5s would be starting. So in this particular block, if you see, or this particular triplet if you see, or this particular triplet if you see, that won't be a correct triplet, or that the condition would be failing. So in that case, that your count that you were actually dealing over here, like when you were finding for this as well, so here your count is actually not giving you the exact picture. So here your count should have been reduced to 2, right, to count that how many number of pairs, like how many actually count is being used to like how many cards are actually being used. So here the count would actually be reduced. So if I tell you the exact equation of how do this particular thing would look like, so if your count is, if your s what we have defined this particular thing is, count s. So if this particular count s is greater than equal to 2, so what you have done is you would have simply taken the sum, like sum of all of the counts, right, plus the minimum of count weak comma c minus 2 by 2, like the summation of all of this, like it will be the summation of all of this, like whichever would be the minimum you would be taking that and you would be adding it to the sum. So this is how your problem C would look like. If I show you the code as well, what I have written is, so here is the code as well. So if you see, so what I've done is I've maintained a count 1 and a count 2 and sum and a capacity. So here count 1 is the simply count 1 over here, else it's count 2, and the capacity I'm maintaining as well. I'm maintaining the capacity as well, and the sum is also I'm maintaining. So if your count 2 is simply 0, it would be 0, and if your count 2 is equal to 1, it would simply be the sum that we have discussed over here, this particular C. This would simply work as a sum, and minimum of count 1 comma sum by 2. Else what would have been, it would be sum plus minimum of count 1 plus this particular sum, like this particular is a new sum, or you can term it as a capacity as well. So this would act as your new sum, so that would have been used as a new sum over here. So this is how you would be solving the C problem. I'm sure you would be able to think about how do we actually solve the C problem. And yeah, so that's it. If you like the video, please do share, like, subscribe the channel, and stay tuned for more such contest related discussions. Thank you.